Let's consider an example unrelated to medical devices: running late for work. This example is simple, but illustrates easily how a fault tree analysis diagram can be performed. This FTA analyzes the causes for showing up late at work. You can see that the figure has the structure of a tree that has been laid on its side for our convenience. The top fault appears at the top of the tree, on the far left. So late for work will be the failure mode. There are 3 independent causes of showing up late for work. These can be caused by leaving home late, a traffic jam, or car trouble. The tree continues to spread out to 4 levels in the branch, left home late. The other 2 branches have 3 levels each. You should go 1 level deeper than where you can do a mitigation activity. For example, in the branch woke up late, we have gone 1 step further of the alarm failure. Once the tree structure is agreed upon by your team, the tree diagram can be used to determine the probability of occurrence for each branch and ultimately for the top fault. It is common practice to start at the bottom and work our way to the top. In our example, the commuter drives the car 20 days a month and 240 days a year. Where OR gates are identified, the probability of underlying causes are summed up. Where AND gates are identified, meaning they can happen at the same time, the probability of causes are multiplied. Don't let this step fool you. Assigning probabilities is not an easy task. In the case of medical devices, you can base the probabilities on similar devices on which you can base the assessment from post-production. If the needed information is unavailable, use industry data to support your estimation. In our example, the commuter has a 50% chance of showing up late to work each day. 50% is a really high value. Depending on the severity of being late, for example, getting written up or being fired, we should implement some actions to mitigate this risk. We can prioritize the branches with higher risk probability of failure. Once the FTA is prepared, you can transfer the information from the tree into an FMEA spreadsheet to complete the risk assessment. The FMEA format completes the tracking of risk controls and documents the verification of effectiveness needed to ensure that all risks have been appropriately addressed. FMEA complements the FTA process because the FTA structure is not designed to support an easy evaluation of the acceptable risks. The tracking of the activities implemented and the verification of mitigation actions are difficult to follow in an FTA tree. So you will need to transfer the overall risks, the identified causes, and their mitigation actions from the FTA to the FMEA. In an FMEA, the top-level fault is usually broken down into lower-level faults. Each of these levels has a smaller probability of occurrence. As a result, each lower-level cause might be considered acceptable, even though when you add up all the individual risks, the overall risk is unacceptable. That is why, by using the FTA approach, you are able to identify the probability of occurrence for the top-level late-to-work fault 50%, which is not generally captured with a typical FMEA. The objective is to keep the top-level fault from occurring. The focus needs to be on overall safety.